All right, so I'm recording the class for, this is Thursday, January the 20th for my pre-cal grade 11s. And there we go. Okay, so let's take a quick look at what it says on the blog. There. So we're going to do a few more examples of long division, or maybe even just one more, and then you can kind of try the rest yourself. Then I'm going to show you the shortcut for long division. Now, long division is itself a shortcut, so this is a shortcut for the shortcut. It's called synthetic division, and most people tend to like it better. But warning, it doesn't always work. There's going to be some on that assignment that if you try them, the synthetic division way won't work. We also went through the examples and discussed the ideas in the factor theorem lesson. So that's that booklet I gave you yesterday. Did anybody not get the booklets yesterday? So we'll start in on that today. And then basically I'll just let you have tomorrow as a work period for this little booklet of stuff. And the other thing I did today is I handed out this, the selection sheet that I was promising you the other day. So you got this sheet, if anybody's watching this video because they're stuck at home, and you can of course just download it from the blog, kind of like I just did, just open it from the blog. And then you have until the end of the day Tuesday to get back to me with what option you want to assess. If you read what it says at the bottom here, after the list of all of the outcomes for the course, is it says the outcomes retest is, as its name implies, optional. You don't have to retest anything if you don't want to. You'll be given a test, so I'll get these sheets from you, these handouts from you, and if there's people watching this at home because you're stuck at home, you can just message me on Edsby what your selection is, or selections are. And I will take this sheet and I will put together a booklet that only has the sections you chose. And then staple it, put your name on it, and then when you come in on that Friday, that'll be your test. So you'll be given a test on January 28th comprised of the outcomes you have selected on the sheet. You may select a maximum of 5 outcomes. So don't even try to pick more than 5. Realistically, I don't know that 5 is doable unless they're all small and you really know what you're doing so you can just blaze through them. If you begin an outcome, so if you choose one of them and then you sit down and start writing it, or you choose too many and you just run out of time, when you hand it in, you just tell me which ones you actually want me to mark. If there's one where it's like, well, I didn't finish it, so don't mark that one, or I thought I wanted to retest this one, but I'm still not all that ready for it, I don't think I'm going to beat my old mark, then let me know and we'll just cross it off, and I'll only mark the ones that you want me to mark. Okay? Then, if your retest beats your original score, we replace your original score. Now, your original score might not be out of the same number of marks, but that doesn't matter. I can just use my math skills for proportion to make that work. Like, for example, say you're going to retest T2, which on this is only out of 16, but I think when we tested it was out of like 30 or something, right? So no problem. If the number you get out of 16 beats the number that you got out of 30 in terms of a decimal, then I'll just times that number by 30, and that'll be your new number. It's that easy. Well, I mean, it takes time, but it's not hard. Okay, so that's how it's going to work. So it'll beat, if you beat your original score as a percent, I'll give you that percent of whatever it's out of on Edsby. And that's your new one. Now, if you go down, if your retest score is lower than your original score, I'll average them together. So again, say that you were retesting T2 and you had, say you had 15 out of 30 when you did it, and then you retest it thinking that you know what you're doing, but you don't, and you only get 4 out of 16. Well, then I will take 4 out of 16 plus 15 out of 30, divide by 2, and then times that number by 30, and that will be your new score. Okay, so you got to have, as they say, some skin in the game, right? We don't want people just showing up going, I'll try retesting, why not? I mean, I want to know that you actually put in some effort to improve on an outcome, so that you retest it and know what you're doing. And then, of course, there's the people, I was having this conversation just yesterday with somebody going, oh, you know, I have this outcome where I made a half mark mistake, and I have that outcome where I made a 1 mark mistake. I don't know that these retests are really for you, if that's you. You can try, but I mean, those half-mark mistakes, those one-mark mistakes probably come down to something like you lost track of a negative, you thought 2 times 3 was 5. Those are not, I mean, we're not retesting to sharpen you from 97% to 100%. I mean, if you want to try it, go ahead, but don't come crying to me if you make 2 mistakes on the next time. I would, if I was you, just leave it alone. But that's, I guess, easy for me to say. I'd have been ecstatic with a 97% instead of 100%. But that's just me, I guess. So there you go. There's the rules for the retesting. We're doing it on Friday the 28th, the day that would have been our exam before we canceled our math exams as a department. Any questions? And you can ask. Don't worry, the microphone will pick up your voice, but I won't say your name. Any questions? Okay, so that's how it's going to run. So again, this worksheet, you can take it home, think about it over the weekend, go through EDSB, kind of look at it. And now, some of the things for sure, some of you will be better at, right? Like factoring. How much factoring have we done? Because it's just popped up over and over since we tested factoring. So you might be better at it just from repetition, even though you didn't really work on it specifically. The same might be true of quadratics, because the unit we just did had a bunch of quadratics review, if you think about it. So there's going to be some things like that where it's like, yeah, for sure I want to try to bump up my mark in those ones. But then there's the ones that we haven't thought about in a long time. Like we haven't really touched trig since we finished trig, right? So if your T2 tends to be a popular one for people to retest. So definitely take a look this weekend and go, okay, if I put in a couple days of work here, can I improve on the T2 mark? Right, go back to your old test and see how you do if you rewrote it. Okay, let's move on to other things. So again, Tuesday is the absolute deadline. Where am I? Oh, right. OneNote. Okay, so let's go to this book first. This little booklet here. And let's pick a long division question that maybe we should do together. Let's see, let's pick a tough one. Here we go. These ones here are fairly tough. We have, I'll do 4A with you. We have, let's see, 4A. Let's do this one together. We are going to try to divide x cubed plus 2x minus x minus 2. And we would like to divide that by x squared minus 1. All right. So let's see what we can do with that. Okay. So I'm going to first of all write it in long division form. And already I've done something that you might be wondering, why did he bother writing that? Notice that this bottom term here doesn't have an x term in it. It jumps right from x squared to constant. Well, I kind of might end up needing a placeholder. I could make this plus or minus. It doesn't matter. It's 0 either way. I kind of need a placeholder for when I'm actually doing the long divide. And the same would be true if there was something in the numerator that was missing. Like say that there was no, this is supposed to be a squared, isn't it? Say that there was no 2x squared term. It was just x cubed minus x minus 2. I would write x cubed plus 0x squared so that I had a placeholder in this spot. Okay, now I'm ready to divide. How many x squareds go into x cubed? X of them. Multiply. I know this seems silly saying 0 times anything, but again, it's a placeholder so that my place value works out. And x times negative 1 is negative x. Okay, so x cubed minus x cubed is nothing. 2x squared minus nothing is still 2x squared. And x plus, negative x plus x is nothing, so no x's. Right, and again, I actually leave a placeholder there. Minus 2. And then I'm going to times by 2, because 2 times x squared gives me 2x squared. 2 times nothing is still nothing. And 2 times negative 1 is negative 2. Hey, look what's happening on this one. No remainder. And what does that mean again? When you divide and you get no remainder, what is that telling you? It's telling you that the thing you divided by is a factor of the thing you divided it into. So that means that I know that x cubed plus 2x squared minus x minus 2 factors to being x plus 2, which is the answer that I got when I divided, times the thing I divided by, which is x squared minus 1. And I don't know if you kind of can see this, but suppose this had been a function that I was trying to figure out what it looked like. Because cubics can look weird, right? All parabolas, if you have, like an x squared, no matter what you do to that x squared, even if you change it by putting a coefficient on it, you change it by putting an x term on it and a constant on it, it doesn't matter. It'll always have the same basic shape. Cubics, not so much. Cubics can look like, well, they can look very, very basically like they just changed direction. Or that direction change can get kind of lumpy. And you can end up with 1, 2, 3 x-intercepts. So how do I know what this cubic looks like? Well, if that was my cubic, and now I know what it factors into, I can find its x-intercepts, right? X-intercepts happen when y is 0. And that's 3 different intercepts. Do you see it? Because this factors also, doesn't it? That's a difference of squares. So that factors into conjugate pairs. So I have x-intercepts at -2, -1, and 1. So I now know, if I wanted to graph it, that I have there, there, and there. Now what I don't actually know is how high or low this thing goes. Like how high above those 2 points does it go, and then how low does it go? Oh, I know the y-intercept though. Right? Go back to the original equation. The y-intercept is when x is 0, so 0, 0, 0, minus 2. So this goes through minus 2. But notice this minus 2 isn't in the middle between those two. Well, actually, it is in the middle between those two dots. I just didn't draw a very good scale. So yeah, okay, I'm going to say that maybe it goes as low as that. I don't think it goes any lower, because I actually do know that there is symmetry. A parabola, of course, has the beautiful symmetry of, we even called it the axis of symmetry, right, that cuts the parabola in half. Well, I don't have a line like that for a cubic, but what I do have is that somewhere there's a point where if you rotated it 180 degrees around that point, you'd get the exact same picture. It's called rotational symmetry. So I have a feeling it looks something like that. Now again, this I'm pretty sure is my kind of the lowest point that this little lump goes. We call that a local minimum. But I actually don't really know how high this local maximum is. Maybe I've underestimated it. Maybe it goes up higher than that. Again, there should be some symmetry for the two lumps here, but I don't know what it exactly is unless I learn how to do that in calculus. That's actually one of the things we'll learn in calculus, is how to figure out how high and low the lumps on graphs like cubics and quartics and quintics will actually go to. But I think I've got a pretty good sketch there. Let's see if I'm right about this. So what is it again? It's, you can help me out here. Let me type it in Desmos. So y equals, so what was it again? It was x cubed. Was it minus 2x? Plus 2x squared. And then minus x? Minus x, and then was it plus 3 or minus 3? Oh, minus 2, I'm way off. And there we go. That's pretty good. There's my sketch. There's the real deal. I'm pretty proud of that. I think I'm happy with that. And somewhere I think that point, there's another thing we learned how to do in calculus. What exactly is the point where this thing mirrors itself and has symmetry if you rotated it around that point? Looks like, I don't know, it's around in here somewhere. Desmos doesn't give you that point. You have to figure it out for yourself. And we learn how to do that in calculus too. But the first step, or one of the first steps, is understanding how to find its x-intercepts. -2, -1, and 0. And long division can help us do that. Okay? So there we go. So there's long division. Now, think about how long divide actually works. Let's go back. What was the example I gave you yesterday? Wasn't it 13 into 720? I remember now. That was something like that, right? Okay, now what are you really doing when you do the long division algorithm? You know what you're really doing is you're basically splitting this number into 700s, 2 10s, and no 1s. And then you're just figuring out, well, how many 13s go into this number? Well, it doesn't go in evenly, so how many 10s are left over? And then you slap those 10s onto this number. And then you go, okay, so now how many 13s go into all of these 10s? And then whatever's left over, in this case, will just be my remainder. There is, in algebra, a way to do exactly that by just thinking about this digit, and this digit. Because notice, that's how long division works. You actually play with the digits. You think of this as 72, right? Not as 720 in your first step. Long division has a system for this too, where you can just split the polynomial into just its coefficients. And that's called synthetic division. So let me show you how to do synthetic division. No, get to the rules in a minute. There we go. So example 1, let's do this divide. Okay, so here's how it works. Since x minus 1 is the factor, you take just this value. You remember that you think if x minus 1 is a factor, then x equals 1 is a root or a solution, right? Kind of like working backwards from what I just did a minute ago, right? A minute ago, I was playing with this guy here, and I realized, aha, if those are my factors, their opposite are my x-intercepts, right? So now we're thinking backwards. If this is my factor, then x equals 1 would be the root. So I take that 1 and I put it here, and then I make a little L chart, like so. And on the L chart, I put all of the coefficients and the constant of the thing I'm dividing into. So this is 1x cubed, so a 1 goes here. This is minus 2x squared, so a minus 2 goes here. This is plus 6x, so 6 goes here. And this is minus 12, so minus 12 goes here. Then, the first number always just gets brought down. After that, how much is 1 times 1? Well, 1 times 1 is 1. Now add those two numbers together, I get negative 1. What's 1 times negative 1? Negative 1. Add those numbers together, 6 add negative 1 is 5. 1 times 5 is 5. Negative 12 plus 5 is negative 7. So, since I started dividing by x cubed and I divided by an x, I know that this 1 represents the coefficient in front of the x squared. And I know that this minus 1 is the coefficient on the x. I know that this 5 is the constant. And I know that my last number is my remainder. And that gets me the same answer that I would have got if I had long divided this. So let's try long dividing it just to double check. How many x's go into x cubed? X squared of them. When I multiply that, I get this. And when I minus that, -2 minus -1 is -1. Then I bring down 6x. How many x's go into -x squared? -x of them. -x times -1 is plus x. -x squared minus -x squared is nothing. 6 minus 1 is 5. Bring down the minus 12. How many x's go into 5x? 5 of them, giving me 5x minus 5. And when I subtract that, I get -7. Remainder of -7, 1x squared minus an x plus 5. Two different ways to long divide or to divide polynomials when you can't factor. All right, let's try another synthetic divide one. And then we'll let you try one on the next one. Okay, here's another one where we're missing a value. I have to think of this as 2x cubed plus 5x squared plus 0 x's plus 9. And if I don't do that, this won't work out when I synthetically divide. Okay, so if x plus 3 is the factor, -3 is the potential root. Make my chart, and then use up the coefficients on the thing I'm dividing into. 2, 5, 0, 9. The 2 always just ends up being itself. -3 times 2 is -6. 5 add -6 is -1. -3 times -1 is 3. 0 plus 3 is 3. -3 times -3 is -9. 9 add -9 is 0. Ooh. What's this tell us again? If there's no remainder, that is a factor. So once again, my answer when I divide is 2x squared, because that 2 is right there, minus 1x plus 3. Okay, let's take a look at the rules in written form for what we just did. Rearrange the equation in descending order. Write only the coefficients of the equation. If any are missing, fill in their spot with a 0. Notice on the last one we actually plugged in a 0. Make an L shape with the value of the outside, x on the outside. Bring down the first coefficient, multiply, add that number to the second coefficient. Repeat steps 4 to 6 until there is no more coefficients to bring down, and write the resulting numbers as the coefficients of a new equation, and the last number is my remainder. So there's your steps. Okay, let's follow them one more time. Let's pick one from the homework. Now, we actually can't do this one that we just did here easily by synthetic division, because notice this is not an x, it's an x squared. So I could, if I wanted to, do it in 2 steps. I could divide by x plus 1, I could divide by x minus 1, and then use synthetic division, but that's kind of a drag. And what if this thing didn't simplify like that? What if I couldn't factor it? Then for sure I'm stuck. So synthetic division works best for ones where I'm just dividing by a single power of x. Let's just pick one of these guys. Let's pick f. Oh no, f is, oh, that's going to be, never mind. Here's the other place where synthetic division is actually really hard. What if this thing doesn't have a 1 here? Then I'd be working with -3/5, right? Because that's the actual 0. That's the root of that factor. Bleh. I don't want to do that. So let's see. Let's stick to ones that work. Let's pick anything. Anything from number 2 would be fine. So let's pick one like, let's pick E. So we have m cubed minus 4 plus 3m squared. So m cubed minus 4 plus 3m squared, and divided by m plus 2. Go away. Okay, let me get rid of this. All right, so what was my first step? This 2 is really a -2 when I think about it as a root. Put my coefficients in the right order. The m cubed comes first, the m squared comes second. They didn't give me an m, what do I do? Put a 0. And then the -4 is my constant. All right, bring down the 1. -2 times 1 is -2. Add. Remember, you're not subtracting here, you're adding. 3 add -2 is 1. -2 times 1 is -2. 0 plus -2. And then -2 times -2 is 4. Hey, it's another one with no remainder. Oh, no. Oh, yeah, it has no remainder. -4 plus 4 is 0. So the answer to this is, since this was a cubic and this was a linear, when I divide, it's going to be an m squared. So there's an m squared. There's 1m squared plus 1m minus 2 is my constant, and then there's no remainder. So we're done. And that's synthetic division. All right, I think you should try one without me now. Let's go back to this booklet here. And okay, so we just did example 2 a few minutes ago. Why don't you try, oh, there's no more examples? Oh, okay, well, we'll hit one in a minute. Okay, before we go any further, we have something called the factor theorem. And the factor theorem tells us whether or not the divisor is a factor of the dividend. If there's no remainder, then the divisor is a factor. And we just saw that, right? In the last one we just did, we found out that there is no remainder when I divide this by this. So I know that this thing here is a factor of that. That's it. That's all that the factor theorem says. It's not a particularly deep piece of information. Oops. So there it is, kind of algebraically stated. If x minus a is a factor of some polynomial function p of x, if and only if p of a is 0. So next is something called the integral zero theorem, which basically says that if you expand this, you get that. So notice that this 10 here has to for sure have factors, if it has factors, that are comprised of numbers here that are its own factors. So basically, what you're saying is, you'd say, note possible factors of 10 are, let's see, what are the possible factors of 10? Well, there's plus or minus 1, plus or minus 2, and plus or minus 5. Let's see, yeah. So basically, you'd say if p of x, that's supposed to be a p, if p of x, some polynomial, is ax squared, or ax to some, I guess I should say maybe ax to some n, because again, it could be It could be a quadratic, it could be a cubic, it could be a quartic, it could be to the power of 12. I mean, I don't know that I'd want to deal with a polynomial that long, but you could. And then you have bx to some n minus 1, so that's 1 power less. Cx to then 1 power smaller than that, all the way down to some constant. We'll call that constant, call that capital N. Then I would say that x minus, oh, I need another letter. What have I not used in the alphabet here? I've used A, B, and C. I've used N twice. Once as a lowercase, once as a capital. Let's try a different alphabet. Let's try alpha. There we go. X minus alpha, because all the rest of the alphabet might be in here. Maybe this is a 27-digit or 27-term polynomial. I don't know what the word for that is. Binomial is 2, trinomial is 3, quadrinomial, pentanomial, what's the word for 27? I don't think there is one. X minus alpha is only a factor of p of x if alpha is a factor of n. So in other words, let's play the game backwards from that example above. Suppose I was asked to try to factor x cubed minus 4x squared minus 7x plus 10. That isn't the next example, is it? They give us a different one? Yeah, they do. Okay. Okay, so suppose I was trying to factor that. So if I'm asked to factor, and what was the numbers again? It was x cubed minus 4x squared minus 3x plus 10. And let's play dumb and pretend we can't see the factors that are already there above us. We're starting from scratch. We have no idea what these factors are. Well, the only factors that could exist are factors like plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. I wouldn't bother trying 3, because 3 is not a factor of 10. I wouldn't bother trying to find 4, right? Does x minus 4 possibly make a factor? No, it can't, because 4 is not a factor of 10. So the only numbers I have to worry about are positive and negative, 1, 2, 5, and 10, and combine it with what we just said in the factor theorem. If p of a is 0, then x minus a is a factor. So let's try is x minus 1 a factor? Well, it is if, and again, I have to call this something. Let's call it p of x. If p of 1 equals 0. So let's try it. If x was 1, does that make 0? Well, let's see, that's 1 minus 4 minus 3 plus 10. Is that a factor? 1 minus 4 is negative 3. Negative 3 minus 3 is negative 6. Negative 6 plus 10, is that 0? No, it's not. No. X minus 1 is not a factor. Oh, wait a minute. We know that it is. Did I do something wrong? 1 minus 4.
Isn't it negative 7x?
Did we copy it right? Let's see. Where's the work here? Oh yeah, we did. We copied it wrong. Thank you. There we go. Good eye. There we go. So that's 7 there times 1, which makes that a minus 7, and that works. 1 minus 4 is negative 3. Negative 3 minus 7 is negative 10. Negative 10 plus 10 is 0. Therefore, x minus 1 is a factor. And then you could long divide the x minus 1, get a quadratic, see if you can factor that quadratic. So let's try another one. Completely factor this. All right, if it has factors, the potential factor constants are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. That's what's possible. Do they work? Well, let's try one. Well, let's try 1 first of all. Let's try p of 1. Does p of 1 make 0? That'd be 1 cubed minus 7 plus 6. Oh, that worked with the first thing I tried. 1 minus 7 is negative 6 plus 6 is 0. Therefore, x minus 1 is a factor. So there we go. Cool. We can long divide it. Oh, and do you want to use long division or synthetic division? Should we use our synthetic division since we've only seen it a couple times? Okay. So if x minus 1 is a factor, you put a 1 there, and then you put all these coefficients and constant. And remember, there's 1 missing. 1 for the x cubed, 0 for the x squared, negative 7 for the x, 6 for the constant. The 1 just plain old comes down. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Negative 7 plus 1 is negative 6. 1 times negative 6 is negative 6. If there had been a remainder here, something is wrong, because I actually know already that x minus 1 is a factor. So x minus 1 is a factor, and my next factor, when I divide that out, is x squared plus x minus 6 is also a factor. But hey, remember when you were in grade 5 and you made factor trees? Remember factor trees? If I gave you the factor tree of 24, and I said, make me a factor tree, and you went 8 and 3, done, you're going to lose marks, right? How come? Because I can still factor 8. I'm not done factoring completely. So by the same logic, if you tell me that this thing factors, that p of x is, well, I already know that x minus 1 is a factor, and I know that this thing is a factor, because that's the answer when I divided. I'm not done yet, because it said factor completely. Notice this thing still factors. And there we go, done. We factored completely. And again, why do we want to do this? Because what if we wanted a graph of this thing? This equation will have an x-intercept at 1, an x-intercept at 2, and an x-intercept at negative 3. So it's going to go, oh, and it has a y-intercept of, what's the y-intercept? 6. So let's see. 1, 2, 3, 4, 5, 6. So it's probably something like this. Oh, wait a minute. I think I did that not steep enough. 1, 2, 3, 4, 5, 6. It's going to go something like this. Oh, I missed the dot. It's going to do something like that. And again, you might be going, how do you know how low this goes and how high that goes? Ask me that again halfway through next semester. Not even. Third of the way through. We'll know by then. That's a calculus trick. But I know it's x-intercepts because dividing told them to me. But I had to use what's called the factor theorem. All right. One more. Okay, this one's a little tricky because, oh, it's got this coefficient of -2 on it. So, if this thing factors, they must all be factors of 12, but then divided by 2. I would say if there are factors of function f in the form x minus anything, a, whatever letter you like, where a is an integer, then a is a factor of -12 divided by -2. This number divided by that number. So what are the factors of -6? Well, well, first of all, what are the factors of -12? -12 can have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. So these are my factors of 12. What if I divided all those by 2? So actually, I shouldn't even think about this -6. That might be kind of misleading. Because some of these numbers here you wouldn't think of as factors of 6 because they're going to be fractions. This is what's different about what you learned in grade 5. In grade 5, you stopped your factor tree when you got to whole numbers. But in this case, since I know that my factors have to be factors of 12 that are mitigated by dividing by 2, well, plus, I'll say now divided by 2, the factors I could be looking for are plus or minus 1/2, plus or minus 1, plus or minus 3/2, plus or minus 4, plus or minus 3. Oh, sorry, there should be a 2. Apparently 4 divided by 2 is 4 in my world. Sorry about that. And plus or minus 6. Now, I don't know about you, but I'm kind of hoping I don't have to play with too many fractions. But you know what? We could try one. Why not? So let's see. F of x. Let me write the function down again because it's way up there. Oh, hang on. Go away. There we go. -2x cubed plus 3x squared plus 8x minus 12. Okay. Let's try a half. Why not? Does f of a half make 0? That'd be a half cubed is 1/8 times -2. That's -1/4. A half squared is 1/4 times 3 is 3/4. 8 times a half is 4 minus 12. You know what? I don't even need the answer. Is that going to be a 0? Will that make 0? Let me just look at it. Can you kind of tell that that's not going to make 0? So give up. Nope. X minus a half is not a factor. How about f of -1/2? Is that a factor? Well, let's see. That would be positive 1/4. And this would still be positive 3/4. And this would be -4 minus 12. I think that's even farther from being 0. So nope, not going to work. So we've ruled out those guys. Let's try the ones. Let's try f of positive 1. So that would be -2 plus 3 plus 8 minus 12. -2 plus 3 is 1. 1 plus 8 minus 12. No, it's not that one either. Let's try f of -1. Negative 1 would make this positive 2, positive 3, minus 8, minus 12. Oh man, we're getting colder. Now, I don't know about you, but I don't want to play with any more fractions. These fractions are going to be my last resort. I'm going to jump over to 2's. Let's try 2. Does 2 work? So if you plug in a 2 for x, you're going to get negative 16. If you plug in a 2 for x, you're going to get 12. Plug in a 2 for x, you're going to get 16. Hey, we got a 0. Therefore, x minus 2 is a factor. Okay, I'm going to go back to long dividing now. Why? Because I like it. I'm going to, full disclosure, guys, I don't like synthetic division. Most people, once they get used to it, go, it's way easier. I don't know. I like long dividing. So I'm going to long divide x minus 2 into negative 2x cubed plus 3x squared plus 8x minus 12. So I have to multiply x by negative 2x squared. And then I subtract. So 3 of these minus 4 of these is negative 1 of these. Bring down 8x. I'd have to multiply x by negative x to get to negative x squared. And that gives me 2x for my other term. I'm subtracting that. So that gives me 6x. Bring down the 12. And times this by 6. 6x minus 12. No remainder. So, my other factor besides x minus 2 is negative 2x squared minus x plus 6. I can factor out a negative. And what two numbers times to make 12? Negative 12, but add to make positive 1. I think I'll factor this by decomposition. 3 and 4. So that's going to be plus 4x minus 3x minus 6. I'm going to factor out a 2x. Factor out a 3. And there's my other two factors. Really 3 if you consider the negative 1. So that's negative x plus 2 times 2x minus 3. So therefore, I've kind of run out of room. Therefore, fully factored, what was this thing again? Was it f or q? It was f. Fully factored, f of x is, there's a negative up front. There's the first factor I found, x minus 2. And then there's the two factors I just found by factoring the remaining quadratic. And there we go. That's the factored form. By the way, what's this telling us besides the fact that I found x minus 2? Negative 2 would have also worked back when I was doing this testing here. F of negative 2 would have given me a 0 if I'd have bothered to run it through. And the other one that would have worked, what's the other one that would have worked? If this is a factor, which of these would have worked? That didn't. Both of these would have. That would have worked. One of those would have worked. Which one? Positive 3/2 would have worked. But then I would have had to have actually long divided with it. Blech. That would have been hard. So there we go. That's the factor theorem. Okay, I'll let you play with this one for a while, and I'll give you a hint. Once you divide through by whatever factor you find, if you have an x to the 4 and you divide it by an x, you're going to get an x cubed. So what do you do then? You repeat the process. See if you can find another factor, then divide again. And I don't care which way you divide. You can use long division or synthetic division on these guys. So what do I know? I know that whatever my factors are, if this thing factors, they have to be factors of 72. But this one's a bit of a challenge. What numbers, how many numbers go into 72? I believe 72 is the record, for the 2-digit number with the most factors. I think. How many numbers are factors of 72? 1, 2, 3, 4, 5, oh wait, not 5. 1, 2, 3, 4, 6. 8 for sure, 9. And okay, I've hit the pair, so what's the pair for 6? 6 is 12. 4 is, what's 4? 18. And then what's 3's partner? 3's partner is 24. 2's partner is 36. And 1 is 72. So you got a lot of numbers that you could possibly try there. With any luck, it'll be one of the first ones you try. And don't forget, it could be plus or minus all of these too, right? So I'm going to leave you with that one. We'll go through it maybe together tomorrow. And then I'm going to let you just have some work time tomorrow too. Play with this worksheet with all of the neat new skills on it. Like, oh, and by the way, this is how you do. Wondering where do I practice this stuff? That's how you do number 8. I think was it 8? Oh no, it's not 8. Ignore me. I'm not making any sense. There it is, number 7. Dun, 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 dun. Factor theorem. So you got to factor those using our new skills. But I'll let you try this one first. Okay, that takes us, I think, to the end of this booklet, right? Oh no, there's still. There's. I didn't know that was in here. There's my sum or difference of cubes that we looked at yesterday. Okay, we'll go through that maybe tomorrow too. That'll only take a minute, and then this booklet's done. I didn't even know that was in there. I wouldn't have made you write so much down yesterday. Okay, there we go. So I'll leave you with that one to try. We'll go over it later. Go over it tomorrow. For guys who are stuck at home watching this video, I'll record us going over that too. All right. Just work time now.